Derivatives with exponents. I noticed that many people are struggling to find derivatives of functions with square roots and combinations of some polynomials and products. So I want to give more examples on this to make sure you guys understand this topic. First, I want to review what I showed at the beginning of, well, I always show this at the beginning of many classes, which are properties of exponential functions. This will be crucial for these problems as well. Remember that a to the x times a to the y is a x plus y. A to the x over a to the y is a x minus y, and a to the x to the y will be a x times y. Let me put this in the boxes, these two together, and this two, and this one. Also, remember this, which is how to understand when you see that a is written in the form with m, and then there's a root, n's root. So this is how there's a way to memorize notation. Whoever goes at the bottom, that will be in the denominator over here. So in this case, I know it's going to be m over n, because n is lower, so it goes to the denominator. This is how you can try to memorize this formula. And some, examples are a cube, and then root of 7th power will be a 3/7, and vice versa. A to the 3/7 is a cubed, then 7th root exponent over there. So now how to use all of this when we differentiate. So we ask you to find derivative of, in general, you remember the formula. Okay, let's write more formulas just to make sure we remember everything. X to the n prime. That's what we learned a couple weeks ago. N goes down. Here it is, going down. X, and then decrease the power by 1. Now we know this formula, and this is what we're going to be using for a while. Examples. That means if I have x to the 3/2 prime, and I want to differentiate this function, the rule still applies. 3/2 goes down, so I will have 3/2 x to the, and then the rule still applies, so it's going to be 3/2 minus 1. And then hopefully your algebra is good. So if not, take a pencil and write it down. In my mind, I always see it as 3/2 minus 2/2, because 1 can be 2 or 2, 3 or 3, 5 or 5, whatever you need at the moment. Then 3/2 minus 3 over 2 minus 2 over 2 is 1 over 2. Then it's going to be 1/2. And you can rewrite it back as 3/2 squared of x, but you don't have to. So we don't really require to rewrite the square root. Most of the time we don't. But let me add this formula just in case. The square root of x can be written as x to the 1/2. You guys know that. Also, x to the negative 1/2, what is that? 1 over the square root of x. How come it became 1 over? Because of the negative exponent. Negative exponent tells me that I should go to the denominator. 1/2 tells me that it should be a square root. Now, what if we have combo? So I'm working with 3x squared, and then third root x to the 5 minus 3x 7/3. Can you differentiate that? I will write down y equals, then y prime is. Before finding y prime, I don't want to do it right away. I would collect all the terms and simplify using rules I just showed you. So let's name them rule number 1, 2, 3. I'll be using rule number 1 here, you see, x squared and x 5/3. How do I know? I'm using rule number 4. Rule number 4 will help me to rewrite this part. So let me do it step by step. Before finding y prime, I will first rewrite this as 3x squared times x to the 5/3. So that's rule number 4. Rule number 4 told me this. 5/3 as exponent minus 3x 7/3. I do recommend not to write down slash like I see you guys doing this sometimes and you see it in the books. Actually, if you write it down as a nice looking fraction, you will make less mistakes at the moments when you have to multiply or divide exponents. Trust me, just do it. And again, before I find a derivative, I keep simplifying. Now I'm using rule number 1. Rule number 1 tells me that if I have the same base, x and x, then the exponents can be added because those factors are multiplied. So it's going to be x2 plus 5/3 minus 3x 7/3, which becomes 3x. Now again, you in your mind, you said 2 is 6/3, right? 6/3 plus 5/3, it's 11/3 minus 3x to the 7/3. And this is my y, simplified y. Then y prime will be, let's see what is happening here. 3 stays because that's a constant that's multiplied by the function, so you just copy it. Now, I will take the orange color. This exponent goes down, so we will have 11/3 x, and now you have to decrease it by 1. 11/3 minus 1 minus 3, again copying it. 7/3 goes down. 7/3 goes down. 7/3 minus 3 minus 1. I see in my mind they're already doing it. 3 minus 3, 3/3. And now you just need to simplify. 3 cancels out 3. 3 cancels out 3 is going to be 11x. 11/3 minus 3/3 will be 8/3 minus 7x to the 7/3 minus 3/3, 4/3. And that's the answer. This is how we work with combinations when you have several products with x and y's, and maybe you can just distribute them all and collect the exponents. In this case, we could do it. Then you don't have to use product rule. If you don't do the way I just did, you can do way 2, use product rule. Product rule. Then where is going to be my u? This is my u, this is my v, and then you do u times v. Prime is u prime v plus v u plus v prime u. It will be longer though, but still gonna work. In these examples, we kind of hope you will simplify first. Now, one more example is involving chain rule. What we can do with chain rule. So I see it's a cube root and then 3x squared minus the square root of x. And I want you to differentiate this. Again, if you don't feel comfortable with radicals, all those roots, then rewrite them using property I gave you on the right, number 4, using number 4. So we're going to have 3x, before we're differentiating, 3x squared minus x to the 1/2, everything to the 1/3. And now I will differentiate after this. So I will say this is my y prime. Look at this. This is exactly the same what we just had, but now you know what to do with exponents. So it's a good idea to rewrite first everything. Now, so this was rule number 4. I used rule number 4 here. Now you see chain rule. Do you see chain rule though? I hope you do, because one function here is inside of another function, which is this polynomial. You can call it g of x inside of the cube function. So you basically have g of x to the 1/3. Or anyway, any book teaches you to do it. Some books show you to use it u inside of f, and so on. The first way to do it is you see the outside function first. What's outside function? To know what the outside function is, plug any number and see what's the last step you will have to do to find the answer. If I'm plugging 1, I will have 1 squared times 3 minus 1 to the square root. And then everything raised to the 1/3. Since 1/3 will be the last step, then I know this is outside function. And that's how I know where to start. Chain rule always starts with the outside function. So I see that 1/3 is the last step. Then it's going to be the first step when you differentiate. 1/3 goes down, copy the function inside, because you cannot reach it yet. Kind of the idea, the way I explain. Copy, and don't forget to change the exponent, 1/3 minus 1. You cannot touch it until you finish differentiating the outside function, because it's not reachable yet. Now times, and this is where the chain rule steps in. Chain rule says, now it's time to look inside. I'm looking inside and I see either over here or in the original function, and I see there's a quadratic function there, or a polynomial. And now I can differentiate that times the derivative of the function inside, which is 6x minus 1/2 goes down, x 1/2 minus 1. Simplify everything or something. 1/3, 3x squared minus x to the 1/2. 1/3 minus 3/3, negative 2/3, times 6x negative 1/2, x to the negative 1/2. Because 1/2 minus 1 is negative 1/2. If we don't ask you to simplify more, this is good enough. And actually here, there's nothing else to simplify here. Now, what else? When you have fractions, let's do one more example with fractions, and I think you're ready to go. It's going to be something like 3x squared over x 5/8. Can you differentiate this? Using property number 2. Property number 2, I see, oh, I don't have to do quotient rule here if I actually simplify everything. Since I have the same base, x, and different exponents, I can say that this is going to be before I'm differentiating. I will have 3, then x. And now let's skip a step and see what's going on. You see this 5 and 8? This is going to be x to the 5/8. And in the top numerator, it's x to the 1/2. So property says top minus the bottom. So 1/2 minus 5/8. Does that make sense? 1/2 minus 5/8. 3 is standing outside over there. 3 is outside. Now simplify and then differentiate. 3x to the, need to create common denominator. To do that, I will multiply by 4. So it's going to be 4 eighths minus 5 eighths, negative 1 eighth. Finally, power rule says when you're differentiating, this 1 eighth goes down, 3 to the negative 1 eighth. X to the negative 1 eighth minus 1. Let's combine negative 3 eighths x to the negative 1 eighth minus 8 over 8. Negative 1 over 8 minus 8 over 8. Negative 9 over 8. And this is the final answer. There are many more examples like this. So if you have more examples to cover, you can let me know and I can make more videos of those. But definitely there's so many different cases. Hopefully this was helpful. And don't freak out when you see square roots or any other radicals. Slowly follow these properties. These properties will save you basically. Remembering how to rewrite exponents will be crucial. And the properties 1, 2, 3 in differentiation. That should be good enough.